All right, Algebra 1. Here we go, guys. We are in section 2 today. We are simplifying rational expressions. This is a good section, and by that I mean it takes a pretty big jump here. Okay, so we've done a lot of these steps before, so I want to start by saying that we have used division with rational expressions already. We've used multiplication with rational expressions, and we have factored. Now we are bringing all of that together, putting all of that into one problem, or we may have to use factoring division, factoring multiplication, and all of that is packed up into one problem. So we're going to do, I think, about 6 example problems in this video. And I know that you're looking at some type notes because I wanted to fit everything into the page that you're looking at. All right. So I'm not going to read every single thing to you. You can do that. I want you to pause the video, and I want you guys to copy down the highlighted portions. If you want to copy it all down, that's even better. But the highlighted portions are covering the really important information. Okay, now do that. I'm going to zoom in. And right here, we are talking about a concept called excluded values. Excluded values, which are discussed in this top paragraph right in here, which you would have already paused and copied down. Excluded values strictly focus on the denominator, not the numerator, just the denominator. So if all they say is what is the excluded values, you can completely forget about the numerator, just focus on the denominator. But if they were to say simplify the expression and state the excluded values, then that's different. That's you doing the whole thing, simplifying, and then that's also you focusing on the excluded values. So that would be both parts. But if all they say is excluded values, let's take a look at just the denominator. Okay, so here are 4 example problems worked out completely right here for you, where we just focus on the denominator equal to 0. Every single denominator, think of it as you are trying to figure out what is the variable. So when we're looking at this first one, 10x, you'll notice make 10x equal to 0. Solve for x, x is 0, right there. Then that means the excluded value is 0. For the second one, 2y plus 14. Make 2y plus 14 equal to 0. Solve for x, or sorry, solve for y. Minus 14 on both sides, and then divide both sides by 2. So a negative 14 over 2 is how they get to negative 7. So you are solving the denominator. Now, example C right here, v squared minus 9. V squared minus 9. Now, can we solve that straightforward? Yes, we can. We can factor it like they've done here. Or we could take that 9 and move it over. And in that case, we could make it look like v squared equals 9 and take the square root of both sides. That would work as well. That's still going to get you the answer that they're looking for of a positive and negative 3 for the excluded values. Now, when it looks like example D right here, that one is a trinomial. And as we've learned in the last chapter, chapter 10, trinomials, we could try to factor that, or we could try to use the quadratic formula for that to solve it. Either way, it's beneficial to try one of those methods. The book in this case starts by going for the discriminant. And the reason why they do that is if you get the discriminant, you will immediately determine if you have 2 values, 1 value, or no values. That's why. If they get two values, then they will proceed ahead and try to solve for it. But when they use the discriminant right here, you get a negative value. And if you get a negative value, that tells you there are no real roots. So that would say there are no excluded values. All right, so we're going to do a couple excluded value problems. Let's move down here. Now, this info typed, this is all about simplifying rational expressions. And again, take the time here, pause the video, copy what you see that I have highlighted. Okay, do that. Then move down here and take a look at these simplified rational expressions. All right, so we have 4 example problems here. We start with one where it is just simple division, crossing out values. We have an r on top, we have an r in the denominator. We can cross those values out, leaving us with just a 1/2. So that's just division with rational expressions. Now, let's take a look at part B. This one, here's our work right here. You'll notice that we have a 5 that's been pulled out of the parentheses, so it is separate from the parentheses. If that is the case, then they are telling you that this is 5 being multiplied by this expression of x plus 2. And if it's being multiplied, then you are allowed to cross this 5 out with this 5 up top. That's what they're doing right there. And then what you have left is x over x plus 2. That can't go anywhere. Please, please, please listen to this next part. You are not allowed to cross out those x's. That is not allowed. It's not possible. You cannot do that, mathematically speaking, because this x is totally bonded to this 2 because of that plus sign right there. It is x plus 2. That is the expression. You cannot just take the x away. It is bonded to the 2 because of that plus sign. So this expression is x plus 2. You can't take the x out by itself. That's super important and something that you will have to remember throughout this whole chapter. All right, so let's take a look at example C and D right here. So right here you have 6m cubed minus 12m squared over 18m squared. There's some stuff that we could take out, right? So they factor out a 6m squared right there. Factor it out. Then 6 and 18. You'll notice that those have been taken out. They're not bonded to something like that x was. They're being multiplied. And that is totally different. If they are being multiplied, you are then allowed to cross them out. So the 6 will cross out. 3's left behind. The m squareds will be allowed to cross out because it's multiplication, not addition or subtraction. All right, and then it simplifies down here to m minus 2 over 3. All right, and then this last expression, y over 7 minus y, can't do anything. Those problems are the best. It's already simplified. So that one's done as is. All right, let's do some example problems here. We'll get into our video problems. These first 2 are just excluded value problems, which means what do we focus on? The denominator. All right, so zoom in, just the denominator, 3x minus 5 equals 0. Solve for x in the denominator. Add 5, add 5. 3x equals 5. Divide both sides by 3. And that is our excluded value, 5 over 3. Solve the variable just in the denominator. Make the denominator equal to 0. All right, let's take a look at number 2. Now we have a trinomial. And as we've learned in the past, trinomials could factor, or we could use the quadratic. Let's try to factor, because you have to get better at factoring in this chapter. So we're going to do a lot of factoring. Let's try it here. All right, so we have just the denominator is all we're focused on, which means my numerator, I don't even need to look at it, just the denominator, because all they asked for was the excluded value. So if our signs are minus, minus, in the parentheses, we will go plus, minus. The value of 2, it's prime. It's just 2 and 1. The value of 12, I'm going to start with a 4 and 3. I always recommend, as I've done in the past, that you start with values that are closer together. It's not a guarantee. It is okay to do a little bit of an educated guess and check. 4 and 3 have a better chance of working, at least at the start, than 2 and 6, and usually especially than 1 and 12. So let's start there. All right. So we're looking to create a middle term value of -5. And then don't forget how we check these. Our double smiley face. All right. So let's start. Let's try the 2x here. Let's put the x here. And let's see, we're trying to create that -5. Let's do the 4 here, the 3 here. Let's see where that gets us. So we got to follow our lines, okay? And like I said, educated guess and check. Keep practicing, keep practicing. 3 times x, that's 3x. 2x and a -4 make a -8x. And wouldn't you know it, there we go. 3 minus 8 equals a -5x. That right there is what we were looking for right there. We're not done yet, but we did the hard part. We factored it, and we know it factors, and it works. So now you need to solve the parentheses and set them each equal to 0. So this one over here, 2x plus 3 equals 0. This one right here, that easy enough, just that's the opposite. That one's going to be 4. So that one, x minus 4, it's the opposite, +4. Right here, subtract 3, subtract 3. 2x equals a -3. Divide both sides by 2. And that is it for those two excluded values. A -3 over 2, a +4. All right, so that's example problem number 2. Now we're simplifying. We're looking at the whole problem. We're going to do 4 of these problems. All right, so here comes number 3. All right, let's start by imagining that we are just focused on the numbers, then the variables, and then put it together. So 4 over 22, that can be reduced. They can both be reduced by the number 2. So 4 over 22 can reduce to 2 over 11. Take a 2 out of each. Then we need to look at the variables. We have 3 x's up top. We have 6 of them in the bottom. Another way to think of this is you have x, x, and x, but on the bottom, we have 6 of those. So look at what we can cross out. That's what we can cross out, meaning every x on top just got eliminated. But we still have 3 x's left in the denominator, meaning it's x to the 3rd power. We can shorten that up. That is what it simplifies to. 2 over 11x to the 3rd. All right, another way to think of it is all 3 of these got taken in because we had 3 left over. All right, so all of this would be eliminated, leaving 3 behind. That's all we did. I just wanted to visually show you that step there. Okay, let's take a look at example problem number 4. All right. Now, what I see is we can take some values out. We can start to simplify by factoring out like terms. Okay, so let's just first focus on the numerator. Don't become overwhelmed and try to focus on the whole problem. simplify the numerator, then simplify the denominator, then simplify the whole thing. So think of it in terms of 3 big steps, not one big problem, but 3 mini problems. All right, so we have a 2 and an x in common for everything up top. So I'm going to take a 2x out and then rewrite as x plus 4, right? All right, I took a 2 out. There it is. I took a 2 out of the 8, brought me to 4. I took an x out. There it is. So that's why that's gone. And that had 2 of them. There's 1 left behind. So I simplified my numerator. Let's simplify the denominator. Okay? So simplifying the denominator, I see that they both share a 3. Look at what they share. Every one of these problems, if there's something you can factor out, do that first. They both share a 3. Take a 3 out. Rewrite what you have left over. X plus 4. You should see something special here. X plus 4 on top, x plus 4 on the bottom. The whole expression is now identical, meaning the whole expression can be taken out. I can't just take out the x. I can't just take out the 4. But x plus 4, the whole thing matches. Take that out. And here's what you have left over. That is now your simplified answer, 2x over 3. All right, let's move down here. Okay, I definitely can see we can simplify the numerator and denominator. It's all about factoring. So we can factor both the numerator and the denominator. What I see in this numerator is it's a perfect square binomial. It's special. X squared is perfect. 64 is perfect. And the minus sign is there. All 3 parameters exist. So this is a perfect square binomial that will break down into this just right here. X plus 8, x minus 8. Guys, this goes back to chapter 9. This is where you learned it. It's all still here coming back. Now let's take a look at our trinomial. This, by the way, guys, this is another perfect square, but it's a perfect square trinomial. Let's check it out. X squared, it's perfect. 64, it's perfect. And a plus sign right there. Those are the 3 parameters that have to be met for that trinomial to be a perfect square trinomial. So how does it factor? X with x. But this time, plus sign here. Focus on what you see there. A minus sign. That means in here, it's going minus, minus. Now, what's the square root of 64? 8. Take a look at what we got. X minus 8, x minus 8. They can cross out. This x minus 8 has to be left behind. You can't cross out 2 of them with only 1 on top. That's not the case. This is an x plus 8, x minus 8. They're not identical. But these guys, x minus 8, x minus 8, they're gone. The whole expression is gone. This is what you have left over. X plus 8 over x minus 8. Boom. Done. All right, last example problem. I'm looking at 2 trinomials. And again, I'm thinking we are looking at some factoring. That's why I said pretty early on in this chapter, factoring is so important. All right, so let's take a look. Can we factor the top? Break it down, double parentheses, x, x. I see a plus sign and a plus sign, which means in here, plus sign, plus sign. 2 is prime. That's just 2 and 1. So I should be able to do that, 2 and 1. What's 2 plus 1? 3. Perfect. What's 2 times 1? 2. Perfect. This works. It factored. Let's try and factor the denominator. All right, x, x. Again, both are plus signs right here, right here. So plus signs here and here. Factors of 10, 5 and 2, bingo. 5 plus 2 makes 7. That is what I'm looking for. 5 and 2 makes 7. Now look, what do we have in common from the top down to the bottom? I see x plus 2, and I see another x plus 2. So right there, meaning what I have left is x plus 1 over x plus 5. There we go. All right, this is a good section. I know you may already say, nope, I'm not sure what he's thinking here, but it is. This is important because this is setting you up for the future, Algebra 2. All right, let's zoom out. Let's see what we got. Example problems 3 through 6 right there. And 1 and 2 right there. All right, bring your questions if you have them. Bring your notes. That is so important. Don't leave notes at home. Don't do half-hearted notes. It's very important. All right, see you guys in the next one.